Hi, everyone, and welcome to this episode of Crowded Beaker Solves. Today we are again drawing Lewis structures, this time for a molecule of xenon tetrafluoride. And I'm trying to kind of work my way through and do a whole bunch of possible variations of ones that you would see as you're studying chemistry and doing your chemistry homework. You'll see these sprinkled in there. And you might be sitting there being bothered right now by the fact that the prompt says xenon tetrafluoride, and you might be going like, hold on there just a second, because my teachers have always told me that noble gases, see, that's a noble gas. Noble gases don't make compounds. They're noble. They're separate. They're apart from everybody else. What is xenon doing in this molecule? Is just made up? Is this fake or whatever? It's actually not. It's true that noble gases would prefer maybe not bonding with anything and just being by themselves, kind of aloof. But on the other hand, there are some other elements, for example, fluorine, chlorine, sometimes oxygen, which are so electronegative, they really want electrons, they can actually force the noble gases to bond to them, even if the noble gases would prefer not to. So you just kind of have to go with it and understand that those do actually exist a little bit. So we're going to go and do the same exact set of steps. XeF4 is our molecule. And the only difference here is that we haven't seen any noble gases. They already have 8 valence electrons, so just go ahead and get them 8. They're probably going to end up with more than 8 after we bond things to it. But we're going to start with 8. Fluorines have 7 each for a total of 28. And that gives me 36 electrons total. So again, follow the steps, just go with them and do them religiously and you'll be fine. Xenon is going to go in the middle. Fluorine's going to go around it with the dots that fluorine should get to make 8. Do that 4 times. And after I do that, I've used up 32 electrons, and I still have 4 more to go. Now, step 4 of our steps says put those extra electrons on the central atom, even if doing so results in having more than an octet. And of course, xenon will have more than an octet because it started with an octet and we added things to it. So we'll put them on there, and here we have a situation where we have 4 bonds and 2 lone pairs. And if you're starting to learn molecular geometries, you would find out that that is a square planar geometry. It would look like a square, but in a plane, like a flat molecule. Okay, so yes, noble gases do exist in compounds, and now it is your turn. So here's our prompt. Draw a Lewis structure for krypton dichloride, another noble gas containing molecule. And take a moment, pause the video, see if you can get this, and we'll check our answer in 1 second. Okay, so if you drew it and it looks something like this, congratulations on drawing a good Lewis structure for krypton dichloride with 22 electrons. We need the 2 bonds, no double bonds because we already had plenty of electrons to go around, but we ended up with 3 lone pairs on the central atom. And now we have a situation with 2 bonds, 3 lone pairs for a shape or a geometry that is actually going to end up looking similar to how I drew it, which is linear. And that would be one of our geometries. So there you have it, some noble gas containing molecules. You might see them here and there, but follow the same steps as you always normally would. And if you have any suggestions of any molecules you'd like me to draw, send them to me. In the meantime, happy drawing and have a great day.